Assalamu alaikum wa rahmatullahi wa barakatuh. Greetings everyone. Once again, welcome back to telecommunication class. In this class, we are going to talk about transmission media. We will get to know the meaning of transmission media, definition, types of transmission media, the concept of transmission media, and the categories of transmission media. For example, wired or guided, and unwired, which is wireless. And we will get to know each types of these categories. We'll talk about disadvantages, advantages, how to use it, how does it work, and we will take examples of each categories. So I hope that you enjoy this class. So the process of sending any data from one device to another device is actually called transition media. And the media itself, it's any medium that is used to transmit the data in this case. All right. So transition media can be defined as any transmission of data through medium. So there is actually a great relation between what kind of media that you are going to use to transmit the data, whether it's going to be, for example, wireless, or it's going to be a cable. It all depends on your use, and each one of the media that we are going to use has its own proficiency, and has its own advantages and disadvantages, and we are going to discuss that in the coming slides. And when we talk about transition media, we must know what types of transition media that we are going to use. We have two main categories in transition media, which are guided, the wired media, and we have the wireless media. And we are going to actually discuss in details for each one of these types, and we are going to take an example, and I'm going to show you some pictures for each of these media, so we will get more familiar with them, and we will get to know the advantages and disadvantages and so on. The first type of transition media is the wired, which is the guided media. And in this case, we are talking about the medium itself. The medium itself is more important in determining the limitation of the transmission. There is actually quite a number of guided, for example, cables, and each of these types has its own length, has its own capacity, the data rate, and so on. Let's go and see each one of these types, and to get to know the differences. The first type, which is twisted pair, and it's called twisted pair because it consists of two insulated copper wires which are arranged in a regular spiral pattern. And the main purpose of the twisting here is actually because it's going to decrease the crosstalk interference between the pairs in a cable. And the twisted pair actually may be used to transmit both analog and digital transmission as well. And it's actually limited in distance, bandwidth, and data rate. And why actually do we need this kind of a twisted pair? Why it's actually twisted? Because if it's not twisted, it's going to create something like electromagnetic noises. For example, motors will affect the closer wire more than the farther one. And if we can see here in the picture, we can see the sender going to send the data, and here are the receiver at the end of the picture. While if it's not twisted properly, it's going to cause some noises that actually might affect the data rate. Okay, so what are the applications of the twisted pair? It's actually the most common medium, and it's used for a telephone network between, for example, a house and a local exchange, and it's used within the buildings itself to private branch exchange, PBX, and for local area networks, which is called LAN. And the capacity of it between 10 megabytes or 100 megabytes. And for the pros and cons, actually a twisted pair is kind of cheap in comparing with other type of guided cable, and it's easy to actually work with, while at the same time the data rate is considered to be low and for a short range only. So twisted pair, as I mentioned before, it could be actually used for analog or digital. So for analog is actually amplifiers actually needed every 5 to 6 kilometers, while in the digital is actually used either analog or digital signals, and repeaters are needed every 2 to 3 kilometers. And it's actually only for limited distance, limited bandwidth, and limited data rate. So we might consider the transmission characteristics before we actually decide that it's the appropriate guided media that we actually going to use. And when we talk about twisted pair, there's actually two types, which is the unshielded and shielded twisted pair. The unshielded is actually the ordinary telephone wire, and it's the cheapest type, it's the easiest to install, and it suffers from external EM interference. For example, in this picture, as you can see, here is the plastic cover, and then we have twisted pair, 5 pairs. Between each one of them there is actually an insulator, and then finally we have the metal which is going to conduct or transfer the data. On the other hand, we have the shielded twisted pair, STP, consists of a metal braid, and it's more expensive, and actually it's hard to handle. It's very thick and heavy. If you can see the picture and compare between this shielded picture and the unshielded, it's going to be there's actually some differences about the heavy weight of this kind of twisted pair. As you can see, first there's a plastic cover, and then there's actually a metal shield which comes under the plastic cover, and then we have the insulation, and then the copper which is going to conduct or transfer the data. And the unshielded twisted pair actually has many categories. For example, we have Cat 3, Cat 4, Cat 5. Each one has its own capacity of data. For example, Cat 3, it's up to 16 megahertz, and mostly for a voice grade found in most offices. Twist length of 7.5 centimeters to 10 centimeters. Cat 4, it's up to 20 megahertz. Cat 5 up to 100 megahertz. And we have Cat 5e enhanced. Actually, it's an updated type of Cat 5. And then we have Cat 6 and 7. And then we have the coaxial cable, which consists of the plastic cover, and then two types of conductor: the outer conductor, which is the shield, and then the inner conductor, and then the insulator. And for coaxial cable applications, it's very common using to television distribution, for example, aerial to TV, cable TV, and for long and short distance, for long distance telephone transmissions, which can carry 10,000 voice calls at a time and actually being replaced by fiber optic. And for short distance computer system links as well, and for local area network. And for coaxial cable transmission characteristics, could be analog or digital. For analog, we need amplifiers every few kilometers and could carry up to 500 megahertz. And for digital, we need a repeater every 1 kilometers and closer for higher data rates. And for coaxial cable, we have the advantages which are better than twisted pair cable, used as a shared cable network, used for broadband transmissions and higher bandwidth up to 400 megahertz, while in the disadvantages, it's more expensive actually compared to twisted pair cables. The coaxial cables are not actually compatible with twisted pair cables. So these are the advantages and disadvantages that we might need to consider before we actually decide whether to use a coaxial cable. And this is a figure of the coaxial cable connector that we might actually need to connect two coaxial cables together at connecting point when we use repeaters or amplifiers, which is based on whether it's analog or digital. And we do have two types of coaxial cables, which are the thicknet and thinner. Thicknet is actually thicker than thinner, and it's used up to 500 meters long, while the thinner it's used up to 185 meters long. And thirdly, we have the fiber optics, which consists of three main layers: the core, jacket, and cladding. The core might be a glass or plastic, and could be laser or light, a specially designed jacket, and it could be like a small size and weight. And we have two types of fiber optics, which is single mode, as we can see in the picture. There's actually a single connectors, while on the multi-mode we have multiple connectors. In this figure, actually, this is the typical application using fiber optics, whether it's a multi-mode or a single mode converters. As we discussed in the figure, there's actually two types of fiber optic cable, single mode and multi-mode, and the main difference is actually because of the distance. For example, the single mode, it's used up to 2 kilometers and a bandwidth of up to 100 megabytes, while on the multi-mode it's used up to 100 kilometers and bandwidth of 2 gigabytes. And fiber optics, actually, there are very benefits comparing to other types. It has actually a greater capacity, data rates of hundreds of gigabytes, smaller size and weight, lower attenuation, electromagnetic isolation, there's no electromagnetic noise, and it's greater repeater spacing, and for dozens of kilometers at least, not like the other types when we needed repeaters in few kilometers, 5 to 10 kilometers. For the transmission characteristics of the optical fiber, it's actually cheaper, wider operating temp range, lasts longer, and for the injection laser diode ILD, it's more efficient and greater data rate. And the second type of transmission media, which is unguided, the wireless type. We are going to talk about the each type and advantages and disadvantages in details. So the wireless transmission frequencies, actually it's consists of three main types, which are 2 gigahertz to 40 gigahertz. Examples are microwave, highly directional point-to-point satellite, and for 30 megahertz to 1 gigahertz, omnidirectional broadcast radio, and the third type is infrared and local. And for the antennas, electrical conductor or system of use to radiate electromagnetic energy or collect electromagnetic energy. And we have two types, which are the transmission and the reception. Transmission, for example, radio frequency energy from transmitter converted to electromagnetic energy by antenna and radiated into surrounding environment. While the reception, electromagnetic energy impinging on antenna and converted to radio frequency electrical energy and fed to receiver. And for both transmission and reception, mostly used the same antenna. And then for the satellite microwave, it's actually a relay station that receives on one frequency amplifiers or repeater signals and transmit on another frequency and requires a geostationary orbit. For example, the television, long distance telephone, and private business network. And here is an example of the satellite point-to-point link. As we can see here, we have the Earth station here, and then we have the satellite antenna itself. This is the point A to point B, and then it's going to send back the information to the receiver. And then we have the satellite broadcast. In this case, we have the transmitter here, which is going to send to the satellite antenna, and the satellite antenna is going to send back to multiple receiver, as we can see. So this is the source of the data sending to the satellite antenna. This satellite antenna then going to send back the data to multiple receivers. Then we have the broadcast radio, which we are familiar with. For example, the FM radio, omnidirectional, UHF and VHF television, and then the line of sight. And then we have the infrared media transmission. For example, our TV remote. The TV remote control is one of the infrared example, and it could be actually blocked by walls, so it's like very short, and it could be a line of sight or reflection, and it actually modulates the non-coherent infrared light. Then we have the wireless propagation, which has three routes, actually: the ground wave, the sky wave, and the line of sight. Ground wave follows a contour of Earth up to 2 megahertz and AM radio. So guys, make sure to differentiate between AM radio, the type of AM radio, wireless propagation, and the type of FM radio. This could be an easy question in the exam. And then we have the sky wave, and then we have the line of sight. And this is actually an example of the ground wave propagation. We can see here, this is the transmit antenna, and this is the receiver antenna, and it needs to go through the signal propagation through Earth. And this is an example of the sky wave propagation. 2 to 30 megahertz. This is the transmit antenna, this is the receiver antenna, and it goes from Earth to the ionosphere, goes up and down till it's going to be received on the other side, which is the receive antenna. Then we have the line of sight propagation. We have the transmit antenna here, and this is the receive antenna, and it goes directly from the transmit to receive antenna. And then finally we have the multipath interference. For example, this is a microwave line of sight, point A to point B. Okay, and then we have for example a mobile radio. It goes from the antenna here, for example, to houses or offices, to the cars. It goes actually everywhere that we need to use it. So that's all for today's class. I hope it's clear, and please watch the video, and I'm going to upload an additional videos in e-learning to make it more easier for you to understand the topic. And then we will meet tomorrow online. So if you have any questions, please prepare the question, and thank you very much for watching. Bye bye.